So in this section of the video, I will talk about the code for the experiment in which we wanted to essentially have the common cathode 7 segment LED display in which we wanted it to count up. So we wanted it to count from 0 to F, so 0, 1, 2, 3, etc., all the way to F. And then we wanted it to, so whenever we press the switch on the switch that was on the Tibia board. So on the Tibia board, so whenever we would press that, it would essentially stop or pause the counting at that moment that we stopped it. So yeah, and then so first, what I wanted to do was essentially kind of explain the setup of how to essentially get it all set up, and then I will talk about the actual um, code for the experiment part, right? Because first we need to know how to set it up in order for it to work. So if we first look at the setup, right? So basically this part here is essentially just kind of, I guess you could say, defining the all the numbers at which is going to be displayed. So this is basically all these numbers, so 0, 1, 2, 3, 4, 5, etc., all the way to F in hex values. So that's in order for it to work, right? We want it to get essentially in hex values for it to work. So yeah, and then I guess another part, right, would be defining our switches. So instead of having to constantly be writing GPIO data and then setting it to the switch and then setting it to the bit, etc. Instead, what I wanted to do, which was recommended by Professor Ayers-Lin, was to essentially just have the have this value of what the bit is and assign it to switch to the variable switch 1, and then again do the same thing for switch 2. So yeah, so essentially it's all it's doing is just it's addressing the value set to the address of this variable here, and yeah, that's pretty much it. It's simpler because you don't have to. It does create like a cleaner code, and you don't have to constantly be writing like GPIO data this, GPIO data that, and it's just you just have to write the switch variable and stuff. So yeah, so this is always a way to do it, and this is what's going to be further on used in the lab as well as other GPIO data stuff. And then another thing that I kind of wanted to mention too was the GPIO addressing mask. So essentially, what this code here is saying, right? So this is basically kind of like another setup where it's setting up the ports and the pins. So if we look at line 122 here, this is basically adjusting the mask for ports L pins 5 through 0, and it's basically just trying to. The way I thought about it was you're trying to align like the bits with each other, but for the big board, you could just directly assign it. There's no shifting that had to be done because it was already aligned with the proper bits. And then for port F, pins 1 and 2, we did have to shift those 5 to the right, so in order for it to be aligned. And yeah, that's pretty much it. So again, it's just basically getting this value and then setting it to the address. So it's not value, but like setting the the bits to the address of this variable here, and then pretty much all this is saying is that again, it's kind of reiterating this point, but a little bit more elaborately. But yeah, so I just wanted to kind of state that before I actually get into the code of the actual experiment. So yeah, so let's get into the actual code now. So now that we have talked about how to set up our code, I will talk about now the actual code for the experiment. So first, lines 59 through 61 are just initializing our variables, setting up the variables that are needed for us to continue. 63 is just setting up our GPIO. 64 is essentially, so whenever we want the 7 segments, we want the 7 segment LED to essentially start, or yeah, to start at, so whenever we click the button for it to start, we want it to start at 0, right? So that's what this is saying, to first define it and start at 0. And then now we're getting it into the actual code. So basically, again, what we wanted to do was whenever we wanted essentially the 7-segment LED display to count up. So we wanted to go from 0 to F. So 0, 1, 2, 3, etc. all the way to F. And then whenever we press the switch, whenever we press the button, it would essentially pause the counting on where it was at. So if we look here, right, so line 66 through 67 is essentially saying that if the switch is not being pressed, then nothing happens. And let's go on to inside the while loop. So inside this while loop here, so again, it's inside a while loop because we wanted to continue iterating, we wanted to keep on going. So so these two lines here are essentially stating that switch is being pressed is equal to false, right? And read the current state of the switch and set it to the current state switch. So that's what this is saying. That's what lines 7 and 2 is saying. And then essentially here is if falling edge occurs, right? Or yeah, if edge detection occurs, if edge detection occurs, essentially we set these press switch equal to true, right? We want to set this variable equal to true, and then we update it, so we set the current value of the current state of the switch equal to the previous state of the switch, and then if the switch is pressed, we want it to pause the count, right? So that's what this is saying. If the switch is pressed, we want it to pause the count, and then here, if the switch is not pressed anymore, then we want it to continue counting, and essentially we increase I. So this I is then going to be used, right? So whatever this I is going to be used to then display on the 7 segment. So when I is 1, it's going to display 1 on the 7 segment. When I is 2, it's going to display 2 on the 7 segment, and it's going to keep on going, and it's going to count up. And then each is going to have a delay of 20 milliseconds in between. And yeah, that's pretty much it. So now let's look at the results, or let's look at the actual of what it looks like on the actual board and on the actual 7-segment LED.
In this video, I will talk about the results for Lab 3 Experiment 1, in which we were supposed to add an onboard switch that would control this 7-segment common cathode display. And essentially what that button would do was, after a power reset, the counter is stopped, and it would display 0 on the 7 segment. Then when the user, or when I press the switch, the counter will start to count up from 0 to F with a 1 second time interval and roll over again to 0. So, and then after, whenever I would press it again, it would pause. It would pause the count going up, and then when if I would press it again, it would continue. So now let's see this. So again, I used this switch, this onboard switch right here. So I'm going to press it. So after a power reset, right, display 0, I'm going to press it. Starts counting 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, and F. So we know it counts up, and then as soon as I press this button, it's going to pause. See, it pauses at 3. You could pause as many times as I want, as long as I'm clicking this button. It will pause. Okay, and then once I click the button again, it's going to continue. So click it once, pauses, click it again, continues. And yeah, that's pretty much it.